Okay, I want to use this video to actually show how the stack is used. And the program is victim.c. Okay, so this victim.c has two functions. One is the main function. The other one is a function f. So in the main function, we first call function f with the user provided argument. Then we return. Then within function f, we declare a character buffer of 8 bytes. And we use StringCopy function to copy the user provided string into this local buffer. Okay, so that's all. And I already compiled this program using this instruction, using this command. So now I'm going to use Emule Debugger to actually analyze this program. You can see here, when I call this function, right? When I load this program, I already provided an argument. So the argument can actually be set here. Okay, so you can see we already have it. Then how can we find the main function? That's a good question. And so when we use GCC to compile victim.c, it adds a lot of its own code into the final executable. And so we actually can use ID Pro to smartly analyze this binary. And so this ID Pro or ID freeware is very powerful. When I press the space bar here, it will change to this kind of layout. And you can see here, basically it tells you the main function starts at this address. It tells you its text section, the code section, okay? And you can see in front of the main function is our actually function f. Good. So now we know where it is. It's actually at 4015 dB. Then now here, actually I already put a breakpoint to the main function, so we can just run. So you can see now we stop at 4015 dB. How can you set up the breakpoint? Just right click on the instruction you want to give the breakpoint, then you just talk, right? When you talk again, it will disappear, so I'm not going to do it. So now you can see here, we come to the main function. Then the main function actually starts with push EBP. So this is called the old EBP, which is used by previous function. So every function will use EBP, not every function. And most of functions will use EBP to refer to its own argument and the variables. And so now when a new function starts, we should save EBP onto the stack, right? So then when we actually returns, then we will restore the old EBP. So we will not disrupt other functions. But anyway, so that's if you know what is going on here. If you know each instruction, you really don't need care about what is going on here, right? You just read the instruction one by one. That's all you need to do. Okay, so now we actually doing here. And also you can see here is our deal assembly. Here is our register window and register window, right? And this is our stack window and shows the stack. Here is the memory dump, and you can use the memory dump window to show the memory content at any location. And so ESP points to this location, DC here. Okay, so when we do the push, right, it will push 4 bytes onto the stack, so this will decrease by 4. So as we mentioned before in the class or whatever, and so the stack goes down. So it means when we add the data onto the stack pointer, the top of stack referred to by the is ESP actually will decrease. Okay, and so now if we step over, run this instruction, you can see now this will decrease, right? Before it was C, now becomes 8. Good. And so now we are here, and then we move ESP to EBP. So now EBP and ESP will point to the same place, so that we can use EBP to refer to arguments and the variables on the stack. Okay, so now we do this. Now you can see EBP and ESP point to the same location. And then here is for memory alignment. Okay, and so we basically we kind of AND ESP with this one. And you can see before it was 8, right? Last byte. Now once we are done with this instruction, the 8 will be gone. So basically we kind of move the top of the stack downward. We increase the stack. So that becomes 0, right? And then here we actually allocate 16 bytes, 10 in hexadecimal on the stack because we need this space to prepare arguments when we call function f. Okay, so good. So they can see basically here ESP will decrease by 10, right? Decrease by 10 here, by not 10, 10 here. So we really don't care about this. This is a GCC edited function, and it will do some kind of initialization, and we can just ignore it. It doesn't change the stack. And although inside of the function, it will change the stack, but once it's done, the stack will return to the original status. Okay, so we can just ignore this one. Okay, so then we do this. You can see that basically here, ESP, EBP will not change here. So now let's see what we are doing here. So what we are doing here, you can ignore this part and just pay attention to this part. So what it means here, we are trying to get the content on the stack. So the address of the stack is EBP plus C here. So what is EBP? EBP is this one. EBP plus C. EBP is D8, FED8. EBP FED8 here. Plus C, it will become this one. Okay, D8 plus C, it will become this one. So basically, we are moving the content at this address. It should be 00B22901 into EAX. And do you know what is this one? This actually is ARGB. Okay, so ARGB itself is an address. Okay, so let's have a look. Now EAX becomes what? 901, right? This is what I just said. And then what is sealed here, right? This is an address. What is sealed over there? That's followed in depth. You can see this is what they have over there. And so you remember ARGB points to the argument. Actually, at the location of our ARGB, it contains a sequence of addresses. One address refers to one argument. So the first argument is the program name, right? And then the second argument is what? The second argument is the user provided uh, argument. So you can see here EAX, then it's this one, right? 00 B22901, it will plus 4, it will point to here. Okay, so you can see here the EX will become B22914, B22914, it points to here. Then what it does at this instruction is we are going to move the content at this address, that is A829B200, into EAX. So what is saved here? So we need to find out what is saved here actually. Okay, so let me see what is saved here. We move this one, EAX, and EAX. So we need to find this location. Okay, so what is saved? What is at this location? A829B200. And so it will be like this one. Okay, A8. It will move actually this one to, so it will move this one into EAX. So after we run this one, EAX will contain this one. Okay, you can see, right? This is EAX will contain actually EAX B22 B2, it will contain 00 B22988 because it's a little India, right? So it's right. Okay. So you may wonder what is saved at 00 B22988. So we can do the follow them again. You can see basically, and it saves AAAA. So that's why we have AAAA here. Okay. And so now you can see basically, and we are here, right? So now we move EAX, that's the address, to this user provided argument. And we move this one to ESP. So we are going to move, this is where ESP is now. We are going to move the EAX, this one, to here. Good. Okay. So now you can see we have this. So we are ready to call function f. So function f actually will use this argument. Let's see how we use it. So we are going to actually step into, right? Because when we do step into, we can actually run this function. So we're going to do step into here. So before we move on to the next instruction, so again, I want to actually emphasize what call does. So the call will do what? The call will actually push the return address of this function, that will be this one, 4015F9, onto the stack. It will put this to here. So BC, it will put that return address to this location. Okay, then it will jump to the function f. So let's run it. Let's do the step into. Okay, you can see at the BC it will have this address. Good. So now you can see the BC, right? What is the at the stack address? This one, and it contains this value. What is this value? It's actually the address of the NOP here, right? You can see that same thing, 4015 F9, 4015 F9. Good. We are fine. Now we come to here. You can see now we are doing the push EBP again because we want to seal the old EBP, which is used by our main function, onto the stack. And then what are we doing here? So we're going to actually push EBP onto the stack. We'll push EBP onto the stack here. Okay. Then we move ESP to EBP. That's good. Then here, for this instruction, sub ESP to 8, we are actually allocating not 8 bytes, but we really allocate more, right? So you have to look at really the assembly to understand what really is going on for your program. Good. Okay. So then here, what we are doing here is that we are going to actually preparing the stack to call StringCopy. So let's look at what are we doing here. You can see for this instruction, right, at this instruction, and at this location, right, and so we are actually use this EBP to refer to different things. So EBP plus 8. So what is EBP plus 8? EBP plus 8. So EBP is what? It's a B8, right? EBP is B8 here. So EBP is B8 is here, right? So now you remember this is the return address for function f. EBP B8, B8 plus 8. That's basically the argument, right? And we pass to function f. So EBP plus 8. So we are actually copy the value stored at EBP plus 8. Now this one, we are going to copy this one into EAX. So EAX will become this value, B2298988. Okay, right. Then we move EAX to ESP plus 4. Okay, good. So that's actually basically the source address when we call StringCopy, right? So that's basically our user provided argument. So we have to move this to ESP plus 4 here. ESP plus 4 will be this one, right? Oh, sorry. Okay, we come back. Good. Okay, so you can see we move this to here, right? Then we move this EBP minus 10. EBP minus 10. We do D, right? D basically means we just move EBP minus 10, minus down 10, minus 10 to add EAX. So that's where the buffer starts. EBP minus 10, EBP minus 10. So EBP is where? EBP is B8 minus 10. That will be B8, A8. A8 be here. Okay. Good. Yes, A8, right? And then we move actually EAX to the top of the stack. What this really means is that we are going to actually copy the string at this address to the location pointed by this one, right? And we are going to copy the data to this location. That is 61FE88. So 61FE88. So basically, we are going to copy AAA to this location. Okay. If there are more, it will just goes up here. Okay. So let's just call StringCopy and see what happens. It's basically what were it? EBP, right? EBP. It will copy to this one, FE88. FE88. So this one will become AAA. Right? FE88. So you can see it becomes AAA. Okay. And then we come to here. NOP will do nothing. And we do deal here. So what deal does, actually deal is going to copy EBP into ESP. So basically then, and we have free space here, right? And we have free space allocated for the operation here. And so we just deal, we just basically copy EBP into ESP. Okay, I remember I have my slides here, right? What deal does. Let's search it. Okay. Okay, so you can see here, deal will do this. Deal will do two things. One is it move EBP into ESP. It also pop EBP, pop onto EBP. Okay, good. So let's come back. So what will happen is when we perform deal, and the EBP and ESP will to the same thing. And the EBP is where? EBP is B8. B8. Then it will also pop this one into EBP. Okay. So basically, after we run this instruction, we should come back to BC here. Okay. So you can see now ESP will point to BC here. Good. So now you can see we are done with the main body function. We come to return. Return is very special. So what return does is return is going to pop the content pointed to by ESP because it's the top of the stack into EIP. Okay, then it will just run the instruction pointed to by EIP. So what is that? So you can see here, this one will be popped into EIP, right? And so this will be 0015F9. You remember that's basically the return function for the function f, right? That's this one, right? And then because we said it's equivalent to pop this one onto EBP, right? Into EBP, and it will also actually when we are done with this return, and then ESP we point to this location. Okay, so let's have a look. So ESP will become this C0 here. C0. You can see now it becomes C0 here, right? And then here, so we do nothing. Then here, leave performs the same set of instruction, right? Basically, we are restore the stack and to the previous status. Okay, and we run it. Now we do return. Basically means our program is done. It's going to return to this instruction. And if the main function is done, it's going to run the instruction at this address. So I'm just run it. We're done. And so here we show nothing because the program actually did nothing, right?